Okay, welcome back. I've decided to do this lesson in two parts for the screencast. So we're dealing with two concepts, lines with one intercept only. Remember last lesson we looked at lines with an x and a y intercept. This time I'm going to look at lines with only one intercept and what the equations of those look like. And then I'll do a separate screencast for the gradient portion. So let's look at the first part now. So some lines that you work with have only one intercept, and you can see that there's examples of that there on the layout for you. So what that means is they have either an x-intercept only, as is the case with this first line. So this is only an x-intercept. Or they might have a y-intercept only, as is the case with the second one. So it only cuts the y-axis or it only cuts the x-axis. Or they could also pass only through the origin, which is the case with the third picture that there is there. So the origin only is where it passes through, although all of them also pass through lots of other points as well, but they only cut the axes at one point. Lines that are horizontal or vertical, like the first two examples, not only cut only one axis, but they're also parallel to the other axis. So you can see with the first one, it's a vertical line. It only cuts the x-axis, and it cuts the x-axis at point B. So you can see their vertical line x equals b. So b is the value of the axis where it cuts the axis. So that's how you can tell that it only cuts the x-axis. There's only an x variable in the equation. If there is no y variable, it must only cut that axis. You can see it's actually parallel to the y-axis, so that means it's never going to cut it. It's going up at the same level, at the same distance away for the whole time. As I said, the equation's in the form is x equals b, and b is just a number, a constant, and that constant is the x-intercept. Now the second one, the horizontal line, is in the form y equals c, and again c is a constant, and it's where it cuts that y-axis. It's always parallel to the x-axis, just like the other line that we just looked at, and your equation is going to be in the form of y equals c, or y equals a number. No x value in your equation, no x-intercept. So hopefully that's a fairly easy way to remember that. The next one we've got are lines that go through the origin, and you can see here there's examples of a whole stack of different ones, and of course they could go in any direction for the 360 degrees of our four quadrant axes. Now the form that these lines are in is y equals mx. So there's both a y and an x because it's cutting both the y-axis and the x-axis at 0 point, which means the values of both of those are 0. If we substitute into them like we did last time, we'd be substituting zeros. So that gives us 1 point on where to draw it, and we don't know which direction it's going in. Unlike the first two lines, which we knew were parallel to those axes, so we didn't need a second point to draw them. This time we don't know the direction, so we're going to have to substitute another number in to find a second point so we can draw that line. And I will do examples of those three different lines now, so hopefully they make more sense. Any questions? Make sure you ask. Okay. So we're going to sketch the following graph. So sketch the first graph we're going to look at is y equals to 2. Now there's no x value in this equation, no x at all. That means it only cuts the y-axis and it's parallel to the x-axis. It never touches that x. There's no x's there. So what this tells us, this equation, like we looked at before, that 2 is our y-intercept. So our intercept is 0, 2. So 2 is the number for our y-intercept. The other value for our x is 0 because it never ever touches it. So we've now actually got enough information to draw that graph. So y and x, now 0. Now I need values up to at least positive 2 on my y-axis, but I'm going to draw some on both of them. 1, 2, 3, 4, and the point where it intersects my y-axis is at that point. 0 and 2. So I just need to mark that point, and then I need to draw a line which is horizontal or parallel to my x-axis, and of course I should label my equation, y equals to 2. So it's a straight line just like we've had before, but there's only one intercept. Let's look at the next one. So the next one we've got x equals to -2, so exactly the same as what we're looking at just then, but this time we've only got an x-intercept. There's no y's in that equation, and in this case our x-intercept is going to be -2 and 0. So again, we've got enough info to do the drawing, so let's do that. Okay, now we actually need a bit more on this side because our x-intercept is at -2. So I should put some values on the scale of all my axes that I'm drawing, but the point where it's going to cross is that -2 and 0 point. And again, I'm going to draw a line that's parallel to the other axis, and of course I should label it. So again, hopefully that makes sense. Now, this last one. So this is got both x and y in it. There's no constant values. So because there's no constant values, it means that we know that both 0, the x and y intercept must be 0. So it's going to go through our 0 origin. And if we think about that, if we substitute 0 in this equation for y, then x is also going to be a 0 value because y equals 2x. Similarly, if we substitute 0 in for x, then y is going to be a 0 value. So that's how we know that it's going to be a line that goes through our origin. There's no constant value in our number in our equation. There's only x's and y's. So if we substitute into them, they're both going to end up being 0. So because of this, we need to choose another point to substitute and get enough information to plot. Substitute and get a point to plot. We've got 1 point, 0, 0, but we need a second one. So you really could try anything, but in this case, I'm going to try x equal to 1. I could make either my x or my y a 1. I've just chosen 1 because putting 1 into it makes it a really simple equation. So it doesn't really matter which order you do it, just mathematical convention says find out what y is. So that's what I'm doing. I'm substituting in for x. So if x equals to 1, then y equals 2 times 1, which of course equals 2. So the point that we've got from this is 1 and 2. What we're going to do here is plot this, and the line also goes through the origin. The origin. Okay, so let's have a go at drawing it. So again, we need some axes, y, x, 0. Now 1, 2, 3, 1, 2, 3. Of course, they should be even. Mine are not beautiful. Now I know one of my points is there. I also know one is at 1 and 2, which would be approximately there. So they are the 2 points I need to draw my line through. And what that enables us is to tell the direction of the line. So I can see it's only cut both axes at the origin, 0, 0, but it's heading in the direction into the positive quadrant. So that is it for this topic. You need to do exercise 4C. There's a few questions there, only 3 little questions. Once you've done that, we need to move on to gradient. So I'll do a separate recording for that. Good luck. See you in class.